Okay, yeah, great. Thanks for joining us today. So today we're just going to share, I guess, a new partnership that Datamine have formed with Lab3, and particularly their SensorMine product. So I'm fairly eager to talk about that, and I guess the benefits it can bring, I guess, the mining industry. So my name's Essa Immonen. I'm the VP of Customer Experience with Datamine, and I'm joined today by Alain Poinchet, who's a director with Lab3 Lumen, and he'll go through the detail of the product as we get to it. As you were, Datamine's, I guess, continually looking at ways to improve the customer experience. Really looking at ways that we can help our customers reap the full value of their assets, all whilst helping them to control and minimise risk. And this is where we see the SensorMine product really sort of excelling in these fields. But before I sort of jump in, I'll just give a little bit of context the front end. I guess Datamine has traditionally sort of helped the geologists and mining engineers. They've benefited from our products and services through time. We thought it was probably time that the maintenance team also got some benefit from our products and services out on site. Do you mind flicking to the next slide, Alan? And I guess as you can see that Datamine has solutions across the entire value chain. And that's something we've purposely sort of focused on over the years, just so our customers and clients can essentially look at a single vendor, a trusted vendor that can help them through their journey of getting the resource out the ground from pit to port. And that's where we saw partnering with Lab3, as a technology provider, really specialising in the cloud-based solutions, really fitting in. They currently have a strong presence in the manufacturing space, and we can sort of see how we can bring that over to the mining, so that bring that know-how over and hopefully reap the benefits. Just scroll down, Alan. Yep, and so you can sort of see where SensorMine fits in. We're sort of around that operational space there. Christy, would you mind running the first poll? Got a couple little polls on the way, just get a bit of interactivity on the way. So just really want to understand what size operation people are in. So if I give you 10 seconds to quickly answer that, and then we'll just sort of see, just gives the crowd, it enables us to tailor our message a bit more. Okay, I'll give you 3 more seconds. 3, 2, 1, and if you can close it, Christy, if you just present the findings. Yeah, okay, so most people on the call in fairly large operations between 1 and 500 people, so that's great, and I think that's a really sweet spot for this product as well. Just go to the next slide. You just load all of those ones up, Alan, if you can. Save us going through. I guess, maintenance in mining, yes, there's a lot of challenges which we're completely aware. Start with, it's remote. The sites are remote themselves, but then also bits of kit are also spatially spread across sites. And then there's also accessibility issues. So whether it's geography, there's creeks or hills, or whether there's issues with on-site as well. And there's also inherent risks that we're always having to deal with, from a safety perspective. There's mixing of light and heavy vehicles, high temperatures, low temperatures either, noise, rotating parts. And then let's not forget the environment. Got certain license conditions that we need to meet all the time. And then there's a particular sort of level of complexity as well, just interconnectivity of the process, and also the types of equipment that having to be maintained, talking large SAG mills down to small instruments or water balls. And then also have the challenge of availability, of the people. We've got the skills there, or the right number of talented people, when you need them. And then, parts as well. Have you got the parts there, or do they need to be shipped in from somewhere? And so by no means that's a comprehensive list at all, but I guess it's just understanding some of the challenge that our industry faces. Next slide. Yeah, and I guess one of the going down a bit further, a challenge, there's always breakdowns and unplanned downtime, and that's where we really see the SensorMine product coming in. What benefits we have to sort of eliminate, I guess, unplanned downtime and particularly breakdowns. So, look at how do we improve OEE, so the overall equipment effectiveness. So really just trying to get the availability up, improve the performance, and also the quality of the output. It'll enable us to plan our maintenance better, so we can look at what resource availability we have, so have we got the people there, the tools, the spare parts, and also the capital required to do those jobs as well. And then really looking at, minimising the impact on up or downstream. So, if there's something near the end of the process, making sure that we don't miss any sales or shipments or any other interim step along the way. And also, most importantly, that look at improving the risk profile across the sites. So, with better planned maintenance, we're always going to improve our safety. So, I guess with unplanned maintenance, there's always a higher likelihood of exposure to risk because you're haven't got the ability to control all those risks. But then also you have time pressure there as well. And environment again, if there's a breakdown with a pump or something like that, might have some unlicensed discharges. So, and again, that's where the SensorMine product really coming in. It really helps it identify that failure before an actual breakdown and allows us that planning window. And next slide, thanks, Alan. Then, of course, one of the ways we look at trying to minimise or reduce our unplanned maintenance or breakdowns is, having a preventative maintenance program in place. But as we all know, there is a cost to that. And I guess one way I've looked at is, what value leakage is there in the current system? So I guess using inspections as an example, when we go out and look at equipment, there's travel time between locations, and one area that we sort of look at where the leakage comes in that's saying that, we're paying maintenance wages for people to drive around site, whereas we actually want to pay them for their technical ability, not their driving skills. And then there's the time to complete a thorough inspection as well. So it takes time, to measure vibration and temperature. So to do that properly and to trust the results has to be done thoroughly. And also we're putting people in danger there as well. And also those inspections, at best generally we gather point data as well, and we know that trends is where it really allows us to understand the operating conditions. And then the last one, I guess, is the risk management and control. So, what's the cost of putting in risk controls for the people travelling around site or doing inspections? And again, that's where I see the SensorMine product coming in, because it really focuses on the hierarchy of controls, and particularly around that elimination space. So before I hand over to Alan to go into a bit more detail, I'll run another quick poll. Hopefully they'll come up in a second. And so I guess we really want to understand where people are on, I guess, the monitoring ability at the moment. So there's 5 options there. So just pick the one that's most applicable. You might be in a couple of areas, but it just gives us a good understanding where people are at. Okay, give you another 5 seconds. So 5, 4, 3, 2, 1. Okay, and those that voted, yeah, so there's no sensor, so it's all manual at the moment. So yeah, okay, great. That's good to know that there's some opportunity for improvement at your sites. And so on that note, I will hand over to Alan now, and he will delve a little bit more about what the product is. I thought I'd just set the scene. And so thanks, Alan. I'll leave it to you. Thank you.
Thanks, Asa. Yeah, it's really exciting space to be in. First of all, the partnership with Datamine is great to see come together, and they've obviously been really deep across the value chain in the mining sector, and we've been working really hard to improve the sensoring and visibility across sites. And I think that partnership is a really good example of how two technology providers can augment the overall value. Yeah, over the last few years, we've worked really hard to figure out what does it take to increase the visibility across a site. And ultimately, we categorize equipment into a few buckets. Bucket one, equipment that's always had telemetry that is visible through the operations and control rooms. And then there's a bunch of assets that when they were commissioned or possibly are a bit older, that really don't have any sensing on them, but over time might have become problematic, or operations teams might notice that better sensing needs to be put onto those to better forecast when things go wrong. So along that lens, we broke down the key activities that are required to operationalize a sensing capability on those types of equipment. And typically, like as I mentioned, it's a pretty big area in the mining sector that needs to be covered. So wiring and putting the electrical frameworks in place to monitor remote assets or assets that have not been sensed in the past was probably the biggest barrier to entry. It adds an overhead cost, but also the flow of labor to do those activities when they have an existing workload to go tackle really prevented widespread adoption of sensors across other equipment. And so we set about creating an offering that did end-to-end sensing. And it consists of sensors themselves, sensors that we manufacture, but also other third-party sensors that might need to be included in that ecosystem, things that may currently be primarily manually verified. And then all of the cloud technology to bring that data out from those sensors into an environment where we can broadcast it back and do analysis on it. And we also understand that as you put more sensors on site, to make them viable long-term, we need to have all the monitoring and management of that ecosystem of sensors. And SensorMine is all of that together. The analytics, the cloud platform to transport that data, the sensors themselves, and an overlay of managed services monitoring to make sure the sensors are still broadcasting data. But ultimately, what we're chasing is value back to the mining community and sites. And the value can be defined into three key buckets. Number one, the cost of going to take those readings. Number two, when we detect something, detecting it as early as possible so the impact on the site is minimized. And lastly, there's a safety facet to it. Less movement you have on site, the less risk there is that there's an incident or that a light vehicle has a run-in with some larger vehicles. At the core of it, really labor and contract labor represents sort of 30% of the overall cost of running a mine. In some regions, obviously, a little bit less. But if we can chip away at that, we're really reducing overall operational costs. And the things that we can monitor are pretty vast. Just with vibration, temperature, anything that turns, anything that has a harmony to it that we can sense a change in behavior, then we can go tackle those. So things like pumps, any of the mobile assets, gearboxes, belts and motors, pulleys, shaft bearings, and environmental things like boreholes, dust monitoring. Those are all things that we can add a wireless continuous monitoring facet to. On the vibration side, we tackle the vibration analysis in a very specific way. I mean, the industry in a general sense typically uses things like fast Fourier transform to figure out when resonances are shifting over. And temperature is a really good indicator of something going wrong as well. In fact, the way that we view it is that there are early signs of things that are that may cause a future failure. A lot of us have probably noticed our vehicles or cars when they start running at a different harmony or a different noise. It's very telling that something's about to break down. And so we tackle it in the same way, but we use AI and data science to analyze the frequencies and have that continuous monitoring. We believe that as the number of things, number of traits like increased vibration, different harmonies, or increase in temperature, as you notice more of those, then the cost of fixing it also increases, because the failure of the part can cause other effects within the ecosystem of the value chain. And so the earlier we catch it, the lower the cost. As Essa mentioned, spares and parts availability to go fix a piece of equipment that's broken down is really key to ensuring your downtime event is short. So as we detect them earlier, we can plan at the next shutdown to do something about it, make sure all the parts are available, and have a much lower impact on site production. We know for a fact that you can easily sustain losses in the hundreds of thousands per hour if you have a failure on some of your key equipment. And downtime events, 30, 60 hours is not uncommon. So even just catching one of these events can offer a significant return on investment. And lastly, I think safety being essential tenet of right to mine and the ability to justify the social cost of a mine, we're always on the hunt for improved safety on site. We did some interesting research. We looked through the Western Australia databases of all the types of incidents that have happened on site. And as it turns out, plus or minus 30% of the incidents involve light vehicles. It's not surprising. Light vehicles do wander in pretty rough environments, and they're also interacting with vehicles that may not see them. Any impact we can make to reduce the site movements has a huge benefit on OH&S. Those are the benefits. I'm going to talk now a little bit about the types of projects that we've done and sort of explain a little bit the deployments and how we went about those. We've done a fixed plant monitoring project in far north Queensland, and that was really about adding additional telemetry across both the processing plant and some of the assets that were a little bit further out. Ultimately, the goal was to try to right-size the maintenance activities. Over time, this mine had been running for probably 2 decades, and the equipment was aging, and the guys within the maintenance area had to reduce their windows of maintenance to avoid downtime events, and it was getting more and more expensive to keep that pace of maintenance. And so adding sensors to try to better predict when things needed to be fixed rather than very short maintenance windows allowed them to reduce their operational costs, but also
Alan, just for clarity, these sensors are a little black box there with the barcode on there.
Yes, that's right. Yeah, and we have various types of sensors. So some have probes so that we can wire them into the right place. Vibration analysis is very sensitive, and others are mounted directly on the piece of equipment. So yeah, those sensors were deployed on site. We had one gateway running in a central location. The radius of the site, more or less 5 kilometers. And we had the data sampling about every 15, 20 minutes. Our expected lifespan for those sensors, because they're battery powered, is about 3 to 4 years. So it's a pretty good lifespan. The range is pretty good as well. The gateway, which all sensors report back into, was connected via 4G back into the cloud. Of course, we do have capabilities to do Wi-Fi as well. You can see it mounted there on a gearbox and the jaw crusher as well. Jaw crusher vibration analysis was interesting, but we still managed to see abnormalities in the rotational activities of the jaw crushers as the bearings wore down. We also did haul truck analysis, so trying to figure out where the haul trucks were incurring heavier vibrations, and therefore identify areas on the road surface that was rougher and needed additional grading. Tires are, I think, top 4 cost in the mining sector, depending on the region. And so any impact that we can make on reducing the amount of wear and tear on tires has a huge impact on operational costs overall for a mine site. The sensors were a combination of the vibration sensors, of course, but also we had GPS attached to those sensors, so we could tell where in the mine site they were incurring the vibration. We also did some work on gearbox vibration, things like hard shifts or leaving the transmission in a low gear or high gear as they're going up a hill causes repetitive downshifting and upshifting. And their protocols dictated that they needed to choose a gear rather than leaving it automatic. But for drivers, they saw it as a faster way to get up hills, but it has a lot more wear on the vehicles. This is in a project we did in Western Australia. It's a magnetite mine. The view that you're seeing there, and I'll give a little bit of visibility on distances in a minute, probably about 10 square kilometers. And this is to do borehole monitoring. This site is actually quite difficult to drive around. They get quite a bit of rain, and also the terrain is quite muddy. So to get to all the boreholes was quite challenging. And to meet their environmental certification obligations, they have to have a frequency of sampling across all of these boreholes. So they engaged us to do wireless transmission of the borehole data. And we got what I would describe as an epic range. So we got something like 8.5 kilometers up to the furthest borehole, transmitting into one central gateway. The gateway also allowed us to transmit and get data from dewatering pumps within the pit itself. And that project was done over the course of 4 or 5 weeks with a 3-month pilot and a larger deployment at the end. We're also in discussions with this same site to monitor flow of water across the site and monitor pump activity. We've also done some work around digital point cloud processing combined with sensor data. It's a little bit more advanced technology. It allows them to get a little bit more perspective on things like wall slippage and drainage within a site. From a deployment point of view, it's quite simple. Our technology is made up, as I mentioned before, sensors plus a gateway. The gateway is typically powered, although we can put a solar panel on it. And it's usually deployed into an existing comms tower. And it can be either powered through a hard line or powered through Ethernet. So both of those are possible. Its power requirements are quite low. And then you glue the sensors, whether it's directly on the equipment or if you want to have a vibration or temperature probe, that's possible as well. And we then use the mobile app to tag those devices and operationalize them. Once the mobile app is used to tag it through the QR code, it shows up in all the dashboards. From a range perspective, more or less 10 kilometers is what you can expect. If you've got heavy terrain, it's a little bit shorter. The signals do follow terrain, so you don't need to have necessarily line of sight. And we have a bunch of different communication protocols we can use. So in a general sense, if you want to have something battery powered and long range, LoRaN is the best option. And we've done extensive research and development in that space. So we really understand how to set up LoRaN networks and make them function correctly. And in that scenario, you're looking at super power efficiency, very long range, but the data packets are a little bit smaller. So expect sampling every 25 to 30 minutes, maybe all the way down to 15 minutes. And that'll give you a battery lifespan of about 3 to 4 years. We do support Wi-Fi and 4G as well. Wi-Fi is typically used for real-time data, and it has the best data throughput. And it's used typically on equipment where we're requiring super high velocity data, when we're doing sub-second sampling. And we also support 4G and cellular. Those are a little bit more power hungry as well. So Wi-Fi and 4G are typically powered by Wi-Fi, or they can be powered through a hardline. But 4G is typically a little bit more expensive, so the data sampling rate usually ends up being a little bit lower. Our platform is made up of a bunch of different modules. So the monitoring portion, as I mentioned before, we offer a full service to make sure all the sensors are transmitting data. Provisioning, which is done through the mobile app. All the predictive models, so the AI-driven alerts, and I'll drive into that a little bit. Essentially, we're using pattern recognition and deep reinforcement learning to understand the behaviors that are expected out of the data, or what looks anomalous. All of those are baked into the platform. And so we're very, very strong on exception-based reporting. It's not just telemetry that you need to go figure out. We're using AI smarts to make sure that you get only the notifications that matter. We have data storage within the platform to allow us to do further analysis and to pass that back to customers as a batch process. We also provide real-time streaming. So if you want to integrate it into your operations center, you can do integrations through things like OPC UA, so it shows up in your SCADA systems, or any of the operational systems like DCS that you might have in your control rooms. You have an outright notification system, and that can also be tied into the real-time streaming. So our notifications can be shot out the same way that the rest of our data is through OPC UA. And underlying all of this is the workflow to manage, provide device twin capabilities so that we have full visibility over the fleet of sensors that you have on site. From a connectivity point of view, real-time APIs, we have MQTT, the OPC UA publisher, and REST APIs. So that's really excellent connectivity into existing systems if you want to do that. We offer batch data transfers through simple methods like FTP, all the way to more complex methods like data lakes. And we have a full suite of reporting that's baked into the platform. So you can go see how the devices are performing and how your equipment is performing. Bit of a sample of some of the UIs that we've done for other customers. In this case was anomaly detection on a site, and all the text messages that link back to the portal. This is Fort McKay. We've got a bunch of wells and instruments, and you can see the total number of devices, the alarms, and the faults, and create sublocations within it as well. Again, you can see there the list of devices and AI working hard to identify areas of concern. So for example, you might have a vibration analysis that's ongoing, and you're seeing warnings there. Warnings would be associated to anomalous vibration readings that you might need to go have a look at. And things like errors when we have sensors that are going offline for whatever reason, they can be addressed as well. You can then drill down on any of the sensors and go view a detail of the telemetry, along with their alarms and faults. All these dashboards are interactive, and you can choose to slice and dice the information the way you see fit. You can also jump into full data science. So if you have engineers that are dabbling in data science or machine learning, We have direct links into the machine learning environments, and they can go view that data and perform their own analysis, their own predictive models, and redeploy that back into the platform. We use Databricks to do that, and that's a really open platform and has all the open source libraries that you might want or need to achieve that. And then all the alarms associated to that to view the device alarms and have that transmitted back via email or SMS. And again, this is the 3D view, the landscape with an overlay of all the sensors on top. So you can view the full details of your mine site. So if you have any point cloud data or any photogrammetry that you've done already, we can leverage that to give a really advanced view of the site and all the telemetry that's associated to that. And there are deep links into the telemetry, so you can click on any of the icons and view the details of that site. And we do things like elevation, volumetric assessment, and other measurements within that same ecosystem. Lastly, I just wanted to give a bit of an overview of all the things that we do. So obviously SensorMine is our product, but we have our own electronics engineering team. So bring us the really hard stuff to connect to. If you want to bring your own devices, we can help make those communicate in a effective manner back into the cloud, so you get that unified view across all of your assets. And we do excellent connectivity back into industrial systems. So if you're worried about having to change processes within your operations center, we can integrate it directly into that. So it's a unified view across all the sensing that's coming through. That is a quick rundown of SensorMine. Are there any questions or feedback or that you would like to ask? If so, maybe put it in the chat window and we can answer those.
It looks a bit quiet at the moment. While we're waiting that, I know everyone's loving their polls. So I might get Christy to just give another poll now that you've sort of seen their technology. You can sort of see why I guess Datamine is quite excited by partnering with Lab3 and enabling, I guess, a channel for this product to go out to our customers, because we see some real benefits for our customers with this. So I guess this polls, what would be your most compelling reason for using this technology? So there might be a few, but it's just trying to understand where you might see be best to suit your environment. Okay, I'll give you another 3 seconds. 3, 2, 1. So maybe the polls aren't that exciting. Maybe there's too many there to answer. So, but you're right. So it's a case of if there are any other further questions or anything like that, you do reach out to us. We've got a direct link to Alan and his team there, and particularly the Lab in Melbourne. If there are any real detailed questions, I'm sure that we can work through something and solve it. So again, like I said, we're excited to have Lab3 and SensorMine on board. We do see some real benefits of this technology going out to the industry, to save time, money, and also hopefully save some people too.
Esther, I've got one question, which is, what's the time frame on implementation? And typically, we can provision sensors in a couple of weeks, and I guess after that, it really depends on site availability to do the deployment. Our pilot typically lasts between 8 to 12 weeks, so customers can get some good telemetry and understand how the sensors function.
Right.
And I think if that's it, we might say thank you everybody for joining today. And if you have any other questions, please reach out.
Yeah, great. And thanks again for everyone joining. And look forward to answering any questions if they do come through. So thank you.
Thanks, everybody.
Cheers.